Hello everyone, today we are going to discuss about pulse width modulation. This is the one of the type of analog pulse modulation technique. So now in this particular video we are going to discuss about how to generate pulse width modulated signal and how to demodulate the pulse width modulated signal. Here what is the meaning of the pulse width modulation? This is also called as pulse duration modulation. In the pulse width modulation, the width of the pulse is varied with respect to the message signal amplitude. If the amplitude increases, the width of the pulse will increase. If the amplitude reduces, the width of the pulse will reduce. The information is preserved in terms of pulse width variation. So here the amplitude of the pulse is constant, only varying width of the pulse. So because of this, the noise humidity will be more in this pulse duration modulation compared with the pulse amplitude modulation. So here with the simple circuit is available, the comparator circuit is available by using operational amplifier. By using this particular circuit, we are able to generate a pulse width modulated signal. So in the non-inverting terminal and inverting terminal, the two terminals are available in the operational amplifier. In the non-inverting terminal, we are applying the message signal or modulating signal. In the inverting terminal, we are applying sawtooth generator or reference signal. So in both the signals are compared as per the operation of operational amplifier as a comparator. If the input signal, the positive terminal voltage is higher compared with corresponding non-inverting inverting terminal. When we compare the two signal voltages, if positive terminal voltage is higher, we will get positive saturation. So suppose if the negative terminal voltage is higher compared with the positive terminal voltage, we will get a negative saturation. So the comparator always gives only the two output. One is called positive saturation and negative saturation based on the input voltage. So with this we can explain how to generate a pulse width modulated signal by using this particular waveforms. So here the corresponding sine wave representing message signal and sawtooth wave representing your reference signal. So the message signal is applied in the positive terminal of the comparator and the sawtooth signal is applied to the negative terminal of the comparator. So now at the initial condition from this point, the comparator compares both the voltages. Obviously the message signal voltage is higher compared with sawtooth waveform signal. In that particular situation, you will get a positive saturation. That means it will generate a positive saturation output. After this particular time instant, sawtooth waveform signal amplitude is higher compared with message signal. That's why we will get a negative saturation. So till this particular end, we will get a negative saturation. Then again, the second pulse generated from the sawtooth generator, again comparing with the original message signal, during this particular period the message signal is higher, it will generate a corresponding positive saturation. After this particular point, the non-inverting terminal sawtooth generated signal amplitude is higher compared with message signal. So that's why we are getting the negative saturation. So till this particular time duration, we are getting the positive saturation. Now you can see in the third pulse, you are from this particular point to this particular point, we are getting the positive saturation because the message signal amplitude is higher compared with sawtooth. After this particular point, sawtooth waveform amplitude is higher compared with message signal, we are getting the negative saturation. So it depends on the amplitude of the message signal, the width of the pulse is varied. Now in this particular, during the third pulse, the amplitude of the message signal is more, we will get a highest width compared with all other pulses. So that's why here the corresponding the pulse width modulation is performed by using comparator. So this pulse width modulated signal, if you are applying towards the monostable multivibrator, the resultant output is pulse position modulation. So because in pulse width modulation, the rising edges of each and every pulse is common. But the falling edges of each and every pulse, this is the falling edge, this is the falling edge, and this is the falling edge. The falling edges and all different based on the amplitude of the message signal. Then we have to preserve that falling edges by performing the corresponding pulses rising in this particular position. Then we are able to preserve that falling edges. So that will be performed by using monostable multivibrator. The falling edges will trigger the monostable multivibrator. It will generate a short pulse. So the position of the pulse will be different based upon the falling edges of the pulse width modulated signal. Then in the pulse position modulation, the position of the pulse is varying with respect to the message signal amplitude. So this particular pulse width modulated signal we are applying to the detector. We have to demodulate the original message signal from pulse width modulated signal. So at the beginning level, pulse width modulated signal plus noise. After transmitting to a long distance, your pulse width modulated signal is slightly distorted. This signal is regenerated by using pulse generator. That's why the output of the pulse generator, the cleaned signal, whatever may be the ripples or up and downs variations in the original received signal, that will be eliminated and regenerated the pulse width modulated signal. This pulse width modulated signal applied to two different blocks commonly. One is ramp and pedestal generator, another one is reference pulse generator. In the ramp and pedestal generator, during this pulse duration, entire time duration of the pulse width, it will generate a ramp. During the off period, it will generate a pedestal. Similar manner, during the next pulse, it will generate a ramp to the entire duration of the pulse width. So during the off time, it will generate a pedestal. So next, the same pulse width modulated signal applied to the reference pulses. At the end of the pulse, each and every pulse modulated signal will generate a one reference pulse. Both the signals are added together. So we are summing C and D signals. Then the resultant signal is just addition of these two signals. After adding by using the clipper circuit, we are going to fix a threshold and clipped out the required signal. So that will be almost similar to pulse amplitude modulated signal. So here the output of the clipper is F. So pulse amplitude modulated signal. So then this particular signal is reconstructed by using sample and hold circuit and low pass filter. So we can reconstruct the original message signal from the pulse width modulated signal. So the advantages and disadvantages of pulse width modulation: very good noise immunity in the pulse width modulation. Synchronization between the transmitter and the receiver is not essential in the pulse width modulation. The disadvantages of pulse width modulation: the transmitting power will vary based on, because the width of the pulse is continuously varying with respect to the message signal. The bandwidth requirement for pulse width communication is large compared to pulse amplitude modulation. So bandwidth also requiring more in pulse width modulation compared with pulse amplitude modulation. So thank you for watching this video. Then we will discuss with another one topic in pulse analog modulation technique. Thank you all. So try to like, comment, share and subscribe.